Tesla hack was a very interesting one. A team from Germany researched piece of open source software that is called Conman. The Conman Connection Manager is what is in charge in many Linux distributions of maintaining the connectivity, the internet connectivity, making sure that everything is connected, the bandwidth, etc. It's an open source. They reverse engineered it and fuzz test it in order to find, let's call it in-memory vulnerabilities. Okay, in reality, these usually maps to buffer overflows, which map what you see during fuzzing is a crush. A crush means that the CPU now, doesn't go to the right address, and it is exploitable as a cybersecurity exploit if you can actually manipulate that address and send it your way. Okay, this is the technology. The technique is sometimes referred to as return-oriented programming. You are controlling the return addresses of functions on the stack, and through that, instead of returning to your address, the return address is a malicious address, and from there you can run your exploit. This is what this team did. They created an exploit based on a common version that they knew that exists in Tesla vehicles, and were able to actually send this exploit to a Tesla vehicle and take control of the infotainment system.
Great. So the colorful part is they use the drone to actually provide an Wi-Fi access point through which they connected to the Tesla. Some very nice video shoots. But the really interesting part is what they actually bypassed in order to get this exploit to work. Because Tesla was doing quite a lot of things right?
Yeah, Tesla did everything that is considered everything right, the common practice in the industry, which is implementing, enabling ASLR, memory randomization, and enabling stack canaries, which protect crush as a process where when you see that the stack function frames boundaries are passed, but it wasn't enough, and these best practices are not enough, and I think this case shows that these common techniques, so maybe they make the life of the hacker a little bit more difficult, but are not not bypassable, are bypassable.
So what could they do better?
Yeah, so what we are in Karamba Security, what we are pitching, and this is actually the state of the art, consider the state of the art in the cybersecurity industry, is a technique that is called control flow integrity. Control flow integrity verifies the addresses of function calls and returns before the function call or return happens in reality. It means that such attacks that try to manipulate function pointers, either the jump or the return, become impossible if the pointer address is not validated against the whitelist of addresses that was created during compilation time, during link and build time. And this is what Microsoft are doing with their control flow guard. This is what Google are doing in Android with CFI that they've added to CLang. Karamba also provides such a CFI technology that supports many operating systems and many development environments.
Very interesting. So we had an attack, a pretty advanced attack that was done by a rather small team, very strong, but still quite small, limited resources, and still they were able to take over a Tesla.
Yeah.
Although the Tesla was overall doing pretty well in terms of security.
Yeah, generally speaking, the Tesla cars have very strong cybersecurity capabilities already built in. This goes to show that um, at least on externally connected ECUs, like the infotainment in this case, stronger cybersecurity measures need to be implemented in safety critical systems such as a Tesla vehicle.
Makes perfect sense.
Yeah.
So we'll be providing links, first of all, to the presentation itself from those very talented two hackers from Germany,
Mm-hmm.
and also to the blog post that you did about this attack. Thank you very much, and see you next
You're
time.
welcome. Yeah, see you. Thank you, Eddie.